Let's hope that it'll stay. If I even touch this thing.
Don't touch it.
Yeah. Yeah, but give me a chance to get set up in case this thing goes. You know, I might have to ask you a question. I want to move it. I need to be able to see it just a little bit better, but I can't. I'm scared to touch this thing.
Why do you need to move the camera?
Cause I can't halfway see that 5. Move that leaf. Move it. I can't halfway see that 5 over there, and I really need to move this camera. Lord, please don't let this thing jump out of proportion. Good morning, everybody. It is now 10 o'clock. I'm going to go on and get started. I hope everybody had a great weekend. Thank you so much for all of you joining out there. Thank you very, very much. I hope you really did enjoy yourself. Then we're going to jump right into our lesson today and try to get a lot of this work completed. Okay? Good morning to all of you. I'm going to switch it back to the do now so you will be able to see it. Okay? All right. I'm going to give you 5 minutes to work on that. Yeah, I got this on. Okay, let's get started now. Again, good morning, everybody. I'm almost afraid to move around in here because something happens with my phone. I got another one, but I can't get it right. But anyway, let's look at this. We have another system of equations, and I'm trying to finish off these equations so that I can finish that packet, and this is the last one in packet 2. So I sent you this information, and you should have this sheet. So let's look at this system of equations. Here again, we have two equations. We have x plus y equals 375, and we have 1.25x plus 0.75y equals 393.75. The objective here is to look at both equations and decide what we are going to get rid of, which one of these that we are going to work with firstly. But if I were to look at these two equations here, I know that x plus y is easier to work with than that particular one. Plus, I know that I got to know the value of x. So let's look at that. So looking at that then, this is what I would do. I would then say, I would take a negative y from both sides here. I would say x plus y is equals 375. So I would say a minus y and a minus y here. And this cancels out. And I get x plus, I'm sorry about that. X is equals to, x is equals to 375 minus y. Now what you got to remember is this. This is not the true value of the final answer for x. Remember? We got x equals 375 minus y. So now what we got to do, we got to find out what y is before we can find out the value of x. So now let's see what we can do with that then. So now that I know what the value of x is right now, which is not the final answer. This is not the final answer for x. Okay, so now we will continue to work at it. Let me look back here and make certain that you can see what I'm doing. Okay, good job. Now, when I look at this, I then would say, okay, so now that I know that x equals 375 minus y, I will go here and say, okay, 1.25 times what I found out x was, because I need to know what x is. So I found out that it was 375 minus y, and I plug in my other information, plus 0.75y is equals to 393. I hope y'all can see this. 393.75. Let's see if you can see. I know you can't see that. So that should equals to 393.75. Let me see if I can write a little bit better. This space is not enough for me. I write too big. So actually, it's saying 1.25 times 375 minus y plus 0.75y is equals to 393.75. All right. And that's the same thing as I put up here, but you can't see it as well up there, right too big. Now, I want you to look at that particular problem, and I'm going to give you just a minute to see what you think. First step, after I got that. Okay, now, when we look at that, cumulative property, what we are going to do, we are going to multiply everything in parentheses by 1.25. So 1.25 times 375, if you got a calculator, it would be very, very nice if you would just use that. So 1.25, you're going to multiply it times 375, and you're going to get 468. I'm not going to try to multiply this out by hand. If you got a calculator, please use it. Okay, 1.25 times 375 give me 468.75. Then I got to multiply this as well. This is a positive times that negative will give me a negative 1.25y. Okay? Now, after I get that, I got to add everything else that I got here, plus 0.75y is equal to the same thing, 393.75. Now, after I get that, my next step is to collect my like terms. I got a negative 1.25y, and I got a positive 275 here. So I got these two figures here. So they are unlike signs here. So that means I'm going to subtract. And I subtract 1.25y and plus 0.75y. And I get, I know I'm going to subtract because I got opposite signs. And when I do that, I will get 0.5y is equals to, okay, I go back over here and I put my same, bring this number down, and I will get 468.75 minus 0.5y equals 393.75. Now, what would I do next then? My objective is to try to eliminate everything on the side of the y so that I can get y by itself. So when I look at this then, the next thing I will do, I will subtract a negative, because I take its opposite, additive inverse. So it will be 468.75 on this side. And what I do on this side, I got to do it over here. So it'll be a minus 468.75. And when I look at that, okay, so this cancels out. And then I will have a negative 0.5y is equals to a negative 75. Okay? Now, to get the y by itself, I divide each side of the equation by a negative 0.5 or negative 0.5. So a negative 0.5 here and a negative 0.5 here. And it cancels out. And I get y by itself. Y is equal to 150. Now that I know what the value of y is, I can go back over here and find my true value of x. So when I go back over here, I would say, okay, get another color marker. I had x is equals to 375 minus y. Well, I want to find the value of x. So then I would say x is equals 375 minus 150. Now, x true value then is, how much is 150 from 375? I believe it's 225. Yeah, 225. So then I know x is 225. So if I were to look here then, I know that I got my pairs will be, or my solutions will be 225 and 150 for this particular set of system of equations. Any questions? Post it if you do. I'm going to save this on my feed, y'all, so I'll be able to send it to you after the lesson. Now, I have to move on. Again, I'm going to post it on my feed, okay? So you'll be able to see this and go back over it, okay? Now, let's move on with the next one. I don't want to hit this phone system here because I don't want it to go out. Okay, now, our next piece for this morning is, everybody good with this? If you're good, say okay. Type okay if you got it. Type okay. Oh gosh. Okay, I'm gonna post this so you can see it later. Okay. Now, let's move with the next piece. All right. This is the do now that continues today. That continues. And this is coming from work packet 3. Look at your work packet 3. This do now here deals with, we have a trapezoid here, which is labeled G, H, J, and K. And what you want to do, you want to rotate it 90 degrees and you want to reflect it over the x-axis. Well, first of all, when we first began to look here, I got to look at these points. I got G is 63. G is not, the point is not 63. I'm sorry about that. Let me write this down. G is, that's how many degrees the triangle is 63 degrees. That angle is 63 degrees. Okay. But if I were to look at the points here, I would say that G is located right at 0.5. I say this is about a 0.5 for G. And Y for G is a -3. Because this is my starting point with this trapezoid. So I need to know what H is then. H on the x-axis is an 8. And the y-axis is a -3. All right. J on the x-axis is right at 7 and y -6. So it's 7, and where they meet, it's right here. So that's 7, +7, -6. And if I look at K, K on the x-axis is a 2. On the x is a 2. And it's a -6 on the y-axis. So these are my original points. I'm starting with a 0.5, a -3, 8, -3, 7, -6, and 2, -6. So my next step with this particular trapezoid here is that I want to rotate it. Now, when we rotate something, what you got to remember is that the value stays the same, but they stay the same as the prime were, but the sign changes. Okay? So let's look at it. So if I'm going to rotate it 90 degrees, I'm going to flip the coordinate pair. And I'm going to change the sign of the new value. So if I flip the coordinate pair, look at this. These are your coordinate pairs. If I flip them, okay, let's put X and Y over here. If I flip that then, that -3 over here going to be in the X position, and that 0.5 going to be in the Y position over here. So before we do anything, let's just say we're going to flip these answers. We're going to turn it backwards. X going to become Y. Y become X. So let's go. That's when we are rotating it. Let's go over here. We're going to switch it. All right. So X won't be 0.5. X going to be a -3 because I'm going to switch it to rotate it. That becomes a -3. And this becomes, Y becomes a -0.5. Let's don't even worry about the sign right now. Let's just worry about flipping it. So what's going to happen with H then? H going to become a -3. And it's going to be an 8 over here. But remember, I said we'll go back with the signs. Let's just flip it first. And then we got what? So then it's going to be a -6 right here in X and a 7. We're rotating it now. And this going to flip. And this going to be a -6 and a 2. Now, I said when you rotate, you're going to flip the coordinate pairs. And that's what we did. We flipped them. Okay? We flipped them. X became Y. And Y became X. So after we flip them, I'm going to change the sign of the new Y value to negative. It's because they were positive signs, they were positive. So now they're over here, rotating, they're going to be negative. So that's going to be a -8, -7, and a -2. Okay? Again, you take your original points to rotate it, write it over here on the X and Y, but we switch it. We switch the X to Y. And we switch the Y where X will be over here. So see how we did it? X was 0.5. 0.5 on this side when I rotate it is now Y. Okay? And it's negative. You change the sign of the new value and it becomes negative. Okay, so now we want to plot this. So what do? We look here, we say, okay, I got a -3 and a -0.5. So X is a -3. So if I know this is my X scale here. So if I know X is a -3, I'm going to look right here and I'm going to say Y is a 0.05. So I know a -3 and a 0.0. Okay, this is -3 and a 0.05 on the Y-axis is going to be somewhere right in here. Okay? So that's going to be G. That's my new G now. All right, now it's going to be G prime. Really? Because I rotated it. All right, now I got to find H, which is a -3 and a -8. So this is -3 on X and a -8 on Y here. So it'll be here. And this is H. Then I got J, this is going to be H prime. Then I got J going to be a -6 on X, which is right here, and a -7 on Y. So if I were to drive on down here, it'll be somewhere right in here. So that will be J prime. And K for right now would be a -6 and a -2. And I connect my dots. And when I connect them, when I connect my dots, I'm sorry about that, y'all. Every time I get on the phone, you know how people call and I don't even know who they are. So here it is. This became K prime, J prime, H prime, and G prime. So that's how it looked when I rotated it. Okay? I just used my points, my coordinate pairs, or my points that I had. Now, it wants you to reflect it. The second piece, they want you to reflect it across the x-axis. Well, when you reflect this across the x-axis here, you know, when we reflect something, we think of a mirror of it, reflection. So the x value stays the same. Your x value going to stay the same, but your y value sign is going to change to a positive. All right? So let's look at this now. This is G prime and H and J K prime. Now this is going to be double prime when I move it now. So first of all, we got to find out what your values are, just as we found here. So when I look at this, I would say G prime then, X going to be a -3. You're going to keep the same, but you're going to just make it positive. So G prime going to be a -3. G double prime is going to be a -3 and a positive 0.5. It's going to be turned positive. Because when you go to double prime, when you flip it across the x-axis, the y value signs changes to positive. Okay? So now that I got a -3 plus a 0.5, what I'm going to have here? H going to be a -3 and a what? A positive who? 8. Drop in your answers for J and K. What would J and K be? All right? It's going to be a -6 and a positive who? 7. Same thing. We don't have to write positive because it's understood. And here you got a -6 and it's going to be a positive 2. You got to remember now that when you flip it across the axis, the y value changes to positive. When you were doing it down here, finding the prime, the sign of the new values changed to negative for the y. So, those are little rules you got to remember in order to do it. So now let's plot this then. So I know that G prime is a -3. So on the x-axis, if G prime is a -3 right here and a positive 5 on y, it's going to be somewhere right here. Okay, so that's going to be G double prime. All right, now, H double prime is going to be a -3 on X and a positive 8 on Y. So, all right, it's going to be right here. That's going to be H double prime. Okay, so J double prime when I reflect it, or J prime when I reflect it, going to become J double prime. So that's going to be a -6 and Y is a positive 7. So it's going to be somewhere right in here. -6, -6, positive 7. And it's going to be a -6 for, this is J. This becomes J double prime. And K going to be a -6 and a positive 2. So it's going to be right in here. -6, positive 2. That's going to be K double prime. So I just go here and I connect my dots. Same thing. And remember, we said we were reflecting it, so you get a mirror image. Same thing. Okay? And that's how that will look. Any questions on that? This is when we reflect it across the line. This is when I reflect across the line. And this one, I rotated it 90 degrees. Okay? And this was the original. It's where it was originally. We started with these points. We rotated it and found its prime. And then we took the prime and we reflected across the line, the x-axis, and we got double prime. Okay? I'll make certain to share this with you. All right. Any questions thus far? Any questions? I'll post this to you. I don't want to move this thing because it'll get so you can't see it. So I'm going to send this to you. Those points. Okay? And I'll make certain that I write it inside the box so you can see it. But I think you'll be able to see it. It's just that it's the way my camera's set. And I want to move it over, but I'm scared it would lose you. All right, now, what I want you to do next, I want you to take out your sheet that says Day 1 Task, Extended Math. Day 1 Task, Extended Math Application. Take that out. Let me know if you got it. That Day 1 Extended Math Application. It's the one with, it says Day 1 Task, Extended Math, and it has a lot of shapes on it. I sent it to you. It says for each pair of figures, decide whether these figures are the same size and same shape. Explain your reasoning. That's the one I want you to pull up. Or take out. Thought I had mine in here. Okay, hold on a minute. I'm going to give you a minute to get it. Let me go and get mine. I thought I had it in here with me. This is the one I want you to make certain that you have right now. This one right here. This particular sheet. Okay? That's the sheet we want now. I'm going to move this so it won't be a lot of stuff in the way. All right. We're talking about this particular one. Everyone has it. I posted it. Now, let's look at that sheet. Okay. It says for each pair of figures, decide whether these figures are the same size, figures are the same size or same shape. What do you think about the set A? Do you think that they are the same size? What would you say about those shapes? Anybody like to join my live and discuss it with us? Anybody want to join my live? I sent it to you on my feed. All these documents. I sent it on my feed. I posted to everybody yesterday. So go back and look. It's called Day 1 Task, Extended Math Application. You will see all these shapes. Okay? So what do you think about set A? Give me your answer. Do you think they are the same size or shape, and why you think so? Is there anybody want to join my live and talk? Anybody want to join my live? Okay, it says Stuart sent a request. I don't see it showing up here. Can you send me that request again? Stuart 2061? You want to send it again? I don't see it here on my phone. Send me a request. Hurry up. Don't have much time. Come on now. I know you got this piece. Come on. Set A. Y'all know it. Look at the shapes. Let's pretend this is an ice cube, maybe. What kind of shapes are they? Are they triangular, rectangular? What are they? Okay, someone said they are the same shape but rotated. Okay. All right, thank you. Anybody else? Thank you so much. Anybody else want to add something? Okay, good job. Wow, finally got it. Oh, oh gosh, I am pitiful. Do it. Are you here with me? Hi.
Hi.
Don't show your face now. Just let me, okay. Okay, come on, share with us.
They're all the same size.
You're right. They all the same size and same what?
Shape.
Good. And what type shapes do we see here? Are they triangular?
Some are and some are not.
You got two now. I thought you said they were same size and same shape now.
Yes, they are.
We're just talking about set A, okay? So they have these two shapes are the same. And they are rectangles. Did you say that?
Yes.
Okay. What else? You notice anything else?
One shape is faced a different way.
Okay, they facing a different way. Look at the vertex, or the vertices, the angles. Well, what do they do there? See the vertex, the corners? What happens with the corners?
They're pointed in different directions.
Okay. What about opposite? They have opposite vertices cut off? The vertices, you think of that as a corner.
Yeah.
Okay. All right. Anything else?
No.
Okay. Thank you so much, okay?
You're welcome.
All right. Bye-bye. All right, let's look at set B, y'all. The two figures do not, oh my goodness. Let's look at set B. What do you think? Anybody else would like to join my live? What you think about set B? What do we know about them? Anybody want to join? Anybody want to join my live? Got about 5 minutes, that's all. What about set B? Do you think they are the same size and shape? Put your answer, drop your answer in. Let me see. What do you think? Drop your answer in. Do you think these are the same size and shape? Huh? No answers? Is that a little hard just by looking? Someone said yes. Okay, would you like to join my live and explain your yes? Only got a few minutes. Can we measure these things? Is there any way we can measure this? Huh? They somewhat look alike, don't they? But it's really hard to tell whether they are the same without measuring it. And it'd be sort of hard then. It's not easy. So it won't be easy to do this particular one. Not as easy as the other ones because we can measure it. It's hard to tell definitely from looking. Okay? Unless we take some type of measurement or what have you, and that'll be kind of hard. So let's look at set C. Let's look at set C. I'm trying to get here before time. Oh, goodness. Set C. What you think about those? Do you think it's the same size and same shape? Set C. The pink and the blue. Do you think they are the same shape? Huh? The third set. I'll say they appear to be the same size and shape just from looking. It looks like the end points are the same length. Okay? So I would say that they appear to be the same shape. What about set D? The triangular shapes. The fourth one from the bottom. The fourth one from the top. What do you think? Do you think those are the same? Someone says yes. Okay. A lot of people say yes. Each image is a pair of triangles, you know. They look like they have the same size and shape. All the angles appear to be the same. They look like equilateral triangles because they all look equal. Well, you know, they're not glued together in the same way. It appears that the first two have the same size and shape, and the second has the same size and shape. But if we were comparing both, I don't know if we can say that they are equal. They might not be quite equal. I'm talking about for the both two sets. They look comparable to each other. But if I were to look at both pieces, one might be a little bit off, a little bit larger than the other. The one on the right might be a little bit larger than the one on the left. So they might not be the same size and shape. All right, let's look at E. I'm going to send you a sheet with this explanation on it, okay? Let's look at E. What you think? Do you think they are the same size and shape? Drop your answer real quick. What about E? Are they the same size and shape? Huh? E. Set E. Are they the same size and shape? No. You can easily look at that. They do not appear to be the same size and shape. And you can look at those and tell one larger than the other. Okay? All right. That ends our lesson for today. My time is up. But what I want you to do, all those worksheets I posted to you, the ones on homelessness in the United States, I want you to work on those worksheets, and I'm going to send you an answer key to that particular worksheet. Okay? I'll post it later today. All right? Goodbye now. That ends our lesson for today. Bye-bye.